Wow, I bet you have never heard such an epic intro for DNS. But anyways, hello, I hope you are doing well and welcome to another Nielsen Networking video. Now, in case you weren't paying attention to that epic intro, we are going to be talking about DNS in this video, and specifically why you, yes you, need to understand DNS as an ethical hacker, Linux system administrator, Windows system administrator, or anyone pretty much who wants to be a good person. Now here's the thing. We are not going to cover those techniques from the intro today during this video, but here's the truth. You can't do any of them effectively without understanding how DNS actually works first. I mean, imagine trying to poison a DNS cache without knowing what a cache is, or tunneling data through DNS without understanding how queries work. Or heck, even enumerating a subdomain without knowing where the authoritative name server fits into the picture. Good luck. So today we're covering the fundamentals, the DNS resolution process from start to finish. Then, in video 2, we're going to break down DNS record types, the actual data that lives on those authoritative name servers you're going to learn about during this video. You'll learn what A records are, CNAME records, MX records, tech records, every record you want to know about. And not only what they are, but how they can tell a story during reconnaissance. Then, in video 3, we're going to show you how to leverage everything you've learned in the past 2 videos and perform real DNS-based attacks, the techniques ethical hackers use during penetration testing. But before you get ahead of yourself, let's master the fundamentals, starting with what we're going to learn in this video, the DNS resolution process. So let's get started. All right, DNS resolution process. That's what we're talking about. Now, I could simply just do a dig with a trace in a domain and show you the results and we could go through them, but I thought that would be boring. You know, that's not epic. And since we just had that epic intro, we need to keep it real here. So what I did was I wrote a little program here for you. And what we're going to do is this program is going to simulate the entire DNS resolution process. It's an interactive simulation. Sounds impressive, right? So first thing we need to do to kick off this program is we need a website, or a domain, I should say, to simulate the process. I'm going to choose YouTube because chances are you're probably on YouTube right now, unless you're watching this on some pirated website, which unfortunately occasionally does happen. So for us though, we're going to stick with youtube.com, and this will kick off the simulation. So now I want you to imagine you're on your browser. This could also be, Nmap or PuTTY or something else if you were to type in the domain. It could be those programs as well if they have local cache. But the first thing that for our example, it's going to be the browser. The browser is going to check its local cache and say, do you know how to get to youtube.com? And if it does, it will take you there. You'll be happy. You can watch Nielsen Networking videos all day long. If not, it's going to say, I don't know it. Why don't you ask the OS? Okay. Step 2, the operating system. It's going to check its local DNS resolution. That's a fancy way for saying it's going to check its local cache, if you will. Now, what that means on Linux, it's going to be systemd.resolve. On Windows, it's going to be DNS client. Very original for Windows, right? Now, what this is non-persistent cache of everything you've done DNS-wise. As soon as you reboot or you can manually clear it, all that is gone. So it's not persistent. If it doesn't find the information in there that it needs to get to youtube.com, it's going to check your host file. Now on Linux, most Linux distros, this is going to be where your host file is located. On Windows, it's always going to be here as far as I know, unless they decide to change it in whatever they do next. And it's actually not drivers SC. See, I totally just lied to you. It's just going to be drivers. I must have done a typo there. It's going to be drivers without the C/hosts. And there, inside there, there'll be a hosts file that you can edit. But you need, to do either of these, you'll need either root or administrator to access to edit them. And the reason you'd want to edit the host file is if you wanted to overrule your DNS. Let's say you wanted to, when someone put in youtube.com, let's say there was, someone that wasn't up to a little nefarious here and they wanted to redirect your YouTube to their YouTube. That would work. They could put youtube.com in there and then redirect it to their IP address. And that would totally work. And that's actually a common way that, people might compromise a machine and redirect you to their systems, where then you enter your password on YouTube or, God forbid, something worse. And guess what? You just gave them your credentials. But I got ahead of myself. More on that later. We're sticking with the name resolution process. Sticking with that, let's go back and say we don't know what's in the host file. We don't know how to get to youtube.com. It's now going to query the recursive resolver. This is going to be the DNS server that you put in, your Ethernet settings on Windows, or your IP configuration in Linux, or if configuration, however you want to IP, however you want to set it. This is going to be those servers. So it's going to be your 8.8.8.8 for Google or whatever. So anyways, back to that process, it's going to say, do you know how to get to youtube.com? And your recursive resolver, which is the resolver, it's the man, it's going to follow, or the woman, it's going to follow your request all the way through the process, all the way from start to finish until it either finds it or doesn't find it and gives you like a, page can't be displayed or can't find error. It's going to come back to you. But the recursive resolver is recursive because it does just that. It follows the entire process through the DNS hierarchy. So let's say, for the sake of argument, the DNS resolver does not find the address to youtube.com. At that point, it's going to begin the iterative query process, and it's going to query one of the 13 root name servers. And these 13 root name servers are labeled A through M, meaning the FQDN, will have, I'll show you what it looks like near the end of the simulation. You'll actually get to see these root name servers and how they're labeled. They're all over the globe, so they're not all in one data center, obviously, so they're spread out, and they're maintained by different organizations. Most of them, I believe, are ICANN, VeriSign, and a few others, and they do not contain the specific DNS information you're looking for, so they're not going to have the IP for youtube.com. That's not their job. They're there to start the process. So while they don't know the IP for youtube.com, they know where to get you to the next step. Who may or may not know. As we follow the process, you'll get to see where you actually get that information. But that's not the root server's job. They're going to respond with a referral to a TLD server. And we'll go over what a TLD server is in this step right here. All right, in a TLD name server, the TLD stands for top level domain. This means your .org, your .com, your .edu. In other countries, it would mean your .uk, .jp, .bz, .ru, whatever it is. Those are the top level domains. For the purpose of this video, we are actually talking about youtube.com. So we're going to be talking about a .com TLD name server. And it so happens that the .com TLD name servers are all operated by the company we mentioned in the previous step that has a few root name servers, and it's known as VeriSign. So VeriSign, it being VeriSign, hosts all the information about every single .com domain registered, every single one. And first of all, there are multiple .com TLD name servers for redundancy and load balancing and things like this. So when we've gone through the process, we just got referred from the root name server to here, the TLD name server, and now it knows it's a .com we're looking for, so we made it to a TLD.com name server. But at this point, even the TLD name server doesn't know the IP address, but it knows something very important, and that is it knows who is authoritative for youtube.com. It hosts the information that at this step is going to point you to the final step where you are going to get that IP address. So this is a critical step, right? Very important. So I want you to think about what we've done. The root server asks the TLD name server. The TLD server is going to ask the authoritative server. So that's going to be the next step we're going to. But some key points I want you to remember: the TLD name server does not store the final IP address. It returns the record for the domain that you're looking for their authoritative name server. All authoritative servers have to be registered with the TLD name server when the domain is purchased. And it continues the referral chain. So now we're going to go on to the next step, which is step 6, the authoritative name server. All right, and it's finally done it. The recursive resolver has done its job. It has gotten us to the authoritative name server, which is the server that actually contains the DNS records for the domain we're looking for. In our simulation, that is youtube.com. Now, all the other steps along the way have been like a referral, right? Go ask them. I don't have the cache. Go ask here. I don't have this information. Go to that server. All along the way. Now we're actually to the source of the truth for the domain we're looking for. And how does this work? Why is this the source of the truth? Well, that's because every domain out there is registered with a domain register, whether it's namecheap.com, GoDaddy, Google domains, whatever it is, they are all domain registers where UI, YouTube, I guess that'd be Alphabet, whoever it is goes to register their domains. And when you register a domain, you get to decide where your domain points for its name servers. Now you can host your own name servers, or you can use, your domain register's name servers. However you want to do it, you get to decide, okay, when they go to youtube.com, this is the A record that's going to point to this IP address. You got to set that up. This is where it can get a little, if someone were to hack into, it's not going to happen. Well, I shouldn't say it's not going to happen. Let's say someone compromised one of those name registers. They could change all the name records, right? They could go in and point all these major websites to other IP addresses with, malicious intent, right? They could phishing, whatever they wanted to do. That usually doesn't happen. More what's likely to happen is someone might compromise their domain register's login credentials, because once they get into those sites, then they can go in there and they can change your DNS records to point wherever they want. Your A record could now, instead of going to your server, it's now going to their server. Got it? So that's where at this step it can be really dangerous. So I hope everyone understands that you should at least have some sort of MFA on your domain register accounts, if you don't host them on your own. And then you better even have even better security. So anyway, kind of bring you back in here, how this all works. We've registered with a domain. We've set up our domain records, whether it's an A record, C name record, I should say, text, MX, whatever. We're in charge of all that. We get to tell it where to go, and it's authoritative. So it's going to do whatever we put in there. So it will return that record. In the case of the simulation, it returned an A record to youtube.com with this IP address. It's TTL, time to live. This is how long we're telling all those other servers, so like the TLD, all along the way, and more specifically, the recursive name server, which would be, the 8.8.8.8, how long to cache our records. So we're telling it to cache it for 86,400 seconds, which is 24 hours. And you get to set this value. Some only let you go a certain level. I think it will let you go down to maybe 1,500 as on the low end, up to whatever, I think 72 hours on the high end. I'm not exactly sure. I haven't been in there a while, but you do get to pick that. And most authoritative name servers there's not just one of them. You'd have multiple because you need some kind of redundancy, right? If you had just one and God forbid that server happened to go down, no one could get to that site. So we've made it here. We know where we need to go. What do we do next, you ask? Well, let's find out. And we're back at the recursive resolver. Now, at this step, we've done all the work, right? We're back here, and what's going to happen is we don't want to have to do that again, because the recursive resolver is really smart, and it says, I just did all that work. I'm going to work smarter, not harder. So how about you cache that for whatever the TTL was? So that is now cached on that server, which would again be 8.8.8.8 or whatever, and it's going to host that it's going to cache that for 24 hours based on the TTL. So all future queries when I go youtube.com are going to be instant. That won't have to go through that process at all. So that's great, right? That's efficient. That's what we want. Now, what's the final? Well, kind of the final. Well, I guess it would be the final step. So what happens after step 7? How about that? That's a better way to say it, right? Well, let's find out here. Now it goes to your browser. Your browser is connected. You get to youtube.com. Your browser now establishes that TCP IP connection, and then it initiates, your HTTPS. Hopefully you're not using HTTP, because that would be a little shady if you're going to YouTube. But anyway, it opens that up and you are golden. So resolution complete. Let's take a look at the statistics. Quick statistics, I should say. So total time this would take on average would be 20 to 120 milliseconds. On average, there's going to be 4 servers. It's going to be recursive, root, TLD, and authoritative. And multiple steps, 5 to 6 on average. Again, it will vary a little bit, but that's kind of what I would say would be a standard or a benchmark. Key points. Each level of the process, meaning recursive, root, TLD, and on, caches the results for faster future lookups. The resolver doesn't repeat the queries for known domains. It will be instant. The TLD, time to live, remember, determines how long each result stays cached. So the shorter this is, the more often your records will be refreshed. So if you, for some reason, change IPs a lot on your servers, you're going to want this record to, get updated more often, right? Now, some security considerations for ethical hackers, and pretty much everyone, honestly. This doesn't just have to be for ethical hackers. DNS poisoning can happen at multiple levels. Now, I give the example of someone compromising your domain registers account and going in and change records, but this could happen at the host file level. It doesn't even have to get that sophisticated. Someone could compromise your machine and go in and change your host file and point you to a different server. Very simply, right? Once they're in there. I'm not saying it's simple to get in your machine, because hopefully you know what you're doing. But anyways, once they're in, that would be a very simple attack to do, right? DNS queries can leak information about targets. What information do you put in that register, right? You go to MX Lookup, you can look up you can use their tool to look up MX records and it will show you all the information, assuming you're not hiding it behind a proxy domain register. More on that in our next video. You could misconfigure your server and expose an entire DNS zone. And again, more on that in the next video where we're going to cover. I might as well remind you not only to like, subscribe, follow me, and do all that great stuff because you're a good person. But in the next video, we're going to follow up with kind of the second part, which is equally as important as the name resolution process, the records. You need to understand records, all records. You need to understand DNS zones, and we're going to go over that. But we'll keep it entertaining for you because I know this isn't the greatest subject, but ask Amazon or AWS or anyone that uses this. This is important stuff. I mean, it took down AWS for a lot of people. So DNS is something you need to know. But anyways, misconfigured servers can also cause an outage. I didn't list that, but again, ask AWS. DNS tunneling can exfiltrate data. Cache attacks can redirect traffic still, right? There's cache in there in that database. They go in there and redirect you in the database. So again, multiple avenues for ethical hacking. And this doesn't have to be out on the internet. This could be an internal name server at a client, right? A lot of internal a lot of companies host internal name servers for Active Directory or other things like that. So anyways, we are now at the process where we have the chance to see this in real time, and I think we'll do it. What do you guys think? I think we're going to do it anyway because I want to do it. So let's do it. And this should be relatively quick. And I want you to keep in mind when you get up here, you're going to be like, what the hell? We're starting on step 1, which is root. You said that was step 4. Keep in mind, Dig is not your web browser. So you're not going to get the browser doing those steps. You're also not going to get Dig checking your host file because Dig does not do it. We're specifically skipping that step because Dig is a diagnostic tool. Now, when you ping or when you do traceroute or Nmap or whatever, those will use. I'm not 100% sure about Nmap, but I know ping will or traceroute. Those will look in your host file. Dig does not. So we're replacing those steps and we're going straight to step 4, which is now step 1. I know that may be difficult for some of you to follow, but that's where we're at. Anyways, here you go. We're at the 13 root name servers. And here's the TTL on those. And as we scroll down, then we traced youtube.com and now we're hitting the TLDs for the .com name servers. They have a different TTL. And it looks to be, maybe there's 13 of these. I said 13 to 15. Maybe there's 13. Maybe there's a few more, and these are just the results we got. Because they're the first ones that populated. And then it's coming down here to the next step. We finally made it to the authoritative name server, the main one we want to care about. And we get about 4 name servers. So ns1 through 4.google.com. There's probably multiple more of these. These are likely load balanced depending on where you're located. You may have different results if you do this. If you're on the West Coast, if you're in China, if you're in New Zealand, you're likely going to get different results here. Maybe not, but you'll definitely get different results here. And you could probably run this multiple times and you may get different results because obviously there's thousands of Google servers, right? There's not just going to be 4, but they have to load balance them and they can't return you all. So chances are you're going into maybe, X amount of load balancers. Those decide, let's send this traffic here, there, and everywhere. So that's kind of how it works. And that's pretty much the process here. I hope that makes sense. And let me actually get out of here, clean this up, and show you what it actually looks like if we don't use the simulation to make it look all nice and pretty for you. So you could just do a simple dig youtube.com and get a response with the IP address, but we need more information than that. And the simulation was actually using what is known as a trace. So you'd have to go dig plus trace and hit enter. Now, this is actually going to give us more than the simulation because I actually cleaned it up so it was easier to read for you and made it nice. Because here you go. You're gonna start, remember, at the root name servers, A through M, because we're not in a web browser. But you're going to get some extra information down here. And what these are These are for DNS security extensions. It's gonna be a hash that proves that the data is authentic and hasn't been tampered with. And it helps if someone were to try to exfiltrate the zone. This would help protect that information. And then you're gonna also get this UDP information. You're gonna get this because I have IPv6 turned off. So how can we make it look similar? So the first thing we want to do is we want to put in trace, and we want to do -4 there, right? So when we do that, we still get the DNSSEC stuff here, but we're not getting the IPv6. That's still not the same, you say. You're right. So how do we get rid of that? We need one more thing in here. We're going to need a dash, and we're going to need to do no DNSSEC here. And we're going to hit enter. And I must have done that. Let me check this again. No DNS. What am I doing wrong here? Oh my God. It's a plus right here, not a minus. Hit enter again. And this is very similar minus the pretty colors to what you got. So if you're running a trace and you don't have the simulation like I have, go ahead and just run it in this format and obviously replace the domain youtube.com with whatever you wanted. But that will give you an idea of how to look up domains and get your mind so you can start practicing this for our next video, which we will recap this video and then I'll get started on the next one. So why don't we start with the recap? All right, for the recap, I went ahead and created a SVG image that we can view to go over this visually, because I know sometimes it's, well, most of the time it's a pain to just listen to someone speak without being able to follow along. So we're going to review what we did in the simulation. So we started with step 1. We checked the local cache of the browser. We didn't have it, so we checked the OS DNS. Remember, systemd resolve or DNS client. And then we checked the host file, didn't find it there, so we brought out the bad boy, the recursive resolver. We asked it, being whatever we had set up as a recursive resolver, we, for the simulation, used 8.8.8.8, but that could be whatever you have in there. We asked it to go find it for us, go do the heavy lifting. So it started the process, remember? It started the iterative query here. So it went out here and it queried the root name servers, 13 of them worldwide, A through M, all over the globe for redundancy. And load balancing, and it said, I don't know, but I do know where the .com is, so let me send you over to the .com top level domain servers. We went over there. It said, you know what, I don't know where it is specifically, but I know who does. So then it sent us over to the authoritative name server who actually knew the answer. Answer was found. It returns the IP plus the time to live, so that all steps can then be cached in the recursive resolver. It gets that information, sends us in our browser to whatever website we put in, and everything else is history. That is the result of our entire process here. Now, to summarize all that and why it matters because every single time you, or anyone else for that matter, visits a website or uses DNS for anything, the entire process is happening in seconds. And there are billions with a B like a boy, billions of DNS queries happening every single second across the internet. DNS is literally the backbone of the entire internet. And yet, it's invisible to most people, or at least most people don't understand how it works. But when DNS breaks, everything breaks. Remember when AWS went down not that long ago? Because of a DNS issue, entire sections of the internet, apps, websites, and cloud services went dark in seconds, or at least minutes. That's how critical DNS really is. And here's the thing, understanding DNS is not just for those network engineers that had to fix the problem. If you are serious about cybersecurity or ethical hacking, you need to understand the process, inside and out. Because believe it or not, DNS is often the weakest link in a company's security posture. And that is exactly why in future videos, we're going to take a deeper dive into DNS record types, DNS zones, all that stuff. Because once you understand what lives in those authoritative name servers, everything in video 3, which is finally where you're going to get to hear about subdomain enumeration, zone transfers, DNS poisoning, and more. All that stuff I showed you at the beginning will now make sense. And then when we have future videos, you will have that foundation and you will be locked and loaded and ready to go. And you won't be one of those people that doesn't understand how the internet works. And with that, I think we're going to wrap it up here. Thank you for watching. If you found this video helpful, please like, subscribe, and hit that notification bell so you do not miss video 2 and all future videos. Take care and have a wonderful day.